Hello again, tribe. Welcome into the second video of the three-part series of the cubic functions. Now in this second video, we'll be focusing on the second type of questions that they give you into the cubic function. Now if you are new to the channel, please be sure that you first watch the first video so that you can see the first step that I've given you there, so that now you can be able to see what's going to happen into this type of video or this type of a question that you're going to get in the cubic functions. Please don't forget to subscribe so that you won't miss when another video gets uploaded. So without further ado, I'm going to go straight into the question. Now first we're going to read the question and then analyze this type and see, so that you can see the difference between the one that we had in the previous video and the one that we have here, because they have different methods. So let's go ahead and read through the question. Now the question says the graph of h of x is equals to minus 1x cubed plus ax squared plus bx is shown below. A, which is minus 1 is to 3,5, and B, which is 2 is to 10, are turning points of H. The graph passes through the origin and further cuts the x-axis at C and D, right? Now, before we go to the question, what do we need to do? We need to analyze the question, the instructions, and the diagram. So now here in this type of question, we can see that here, the diagram we're given turning points now. Now in the previous video, we were given what? We were given x-intercept. Now the one that we had x-intercept, to call it what? Then x-intercept form. Now the second type now, which is type 2, is what we call what? The turning point form. Now the turning point form has its method, right? Now in the turning point form, here what you do is we're going to apply simultaneous equation. So this is important for you to understand. Whenever you're given a cubic function and you see two turning points, it means it's going to be simultaneous equation. Simultaneous equation. Now how you're going to apply the simultaneous equation, you're going to see onto the when we're answering the question, right? Now here they give you type 2, they give you a turning point, and also of course they have given us another point here. And as you can see here, this next point here is the origin. So here in this case they gave us 0 to 0. So let's go ahead and answer 2.1 and show you the method how you're going to answer 2.1. Now the first question, it says show that a is equals to 3 over 2 and b is equals to 6. All right, now here first we're gonna write in the equation. So h of x is equals to minus 1 x cubed plus ax squared plus bx, right? Then I said we're given the turning points now. Now the turning points, the first one is a is minus 1 is to minus 3,5, and the second one is b, which is 2 is to 10, right? Then also we are given a point which is 0 is to 0, right? Now let's go ahead and answer this. So now here, how are we going to show that a is equals to 3 over 2 and b is equals to 6? So now we're going to use the turning point here, the x coordinates of the turning points. Now in the cubic function, we know that whenever we're talking about what? A turning point, that is where the derivative becomes 0. So this means now here we need to first find the derivative of h of x here. Now what is the derivative of h of x here? So this means the derivative of h of x is going to be minus 3 x squared plus 2ax plus b, right? All right, so now what are we going to do with this? Now here what we're going to do is we're going to take this and then substitute it there. So let's go ahead and do that. So minus 3x squared plus 2ax plus b equals to 0. So now what's the first thing that we're going to do after we have this? So the first thing that we're going to do is we're going to substitute the first x coordinate of the turning point, because you see here the only problem here we have is x and a and b, right? So x is a solution that we have, the first one, which is minus 1, so we're going to go ahead and substitute that there. So let's go ahead and do that. So when you substitute that, when I have minus 3 into minus 1 squared plus 2a into minus 1, right, plus b equals to 0. So now here, if we simplify this, we're going to have minus 3 minus 2a plus b equals to 0. So now this is the first equation, right? Now let's look over again into this part, right? Because this is our equation that we have here. But now in this case, instead of substituting x is equals to -1, let's substitute now x. Let's just do it on this side. Let's rewrite it again here. 3 minus 3x squared plus 2ax plus b equals to 0. So now let's substitute the second x coordinate of the turning point, which is x is equals to 2. Now doing that, we're going to have this squared plus 2a into 2 plus b equals to 0. Now this gives us minus 12 plus 4a plus b equals to 0. So this is the second equation. So now what are we going to do now from this one? So let's open a new space so that we can see this clearly. Now the first equation, if you remember, it was minus 3 minus 2a plus b equals to 0. And then the second one here now, it is minus 12 plus 4a plus b equals to 0. So now from here, we're going to take the first equation and then we want to subtract the second equation, right? So let's go ahead and do that. So this is simultaneous equation by elimination, right? So what is it we're trying to eliminate here? We're trying to eliminate b. So I'm going to take this one and I'm going to subtract with this one. So minus 3 minus minus 12 gives me positive 9, right? Minus 2a minus 4a gives me minus 6a. Now b minus b gives me 0 equals to 0. So this then means here I have a minus 6a equals to 0. Then minus 6a is going to be minus 9 divided by minus 6 divided by minus 6. Then a is 3 over 2. As you can see here, we got the first value for a, right? So let's go ahead and look for the second one. Now the second one, I'm going to take one of these equations because I already have a, so now I need to find b. So let me just take the first one on top here, 0, right? So I'm going to substitute the value for a there, 3 over 2 plus b equals to 0. This is minus 3. This cancels with this. It's going to be minus 3 plus b equals to 0. So minus 6 plus b equals to 0. Therefore, b is equals to 6. And there we go. We got both of the solutions. Now remember in the first one, in the first video, we did it in a different method, and now this is the second method. So please be sure that if you're enjoying the video, subscribe and share it with your friends so that they don't miss this valuable information. So let's go ahead and look into the second question. Now the second question, it says that 2.2 says let's calculate the average gradient between a and b, right? Now it's an average gradient, so let's go ahead and look for the coordinates of a. Now a was minus 1 is to 3, 5, and b 2 is to 10, right? An average gradient is going to be MAB, right? It's an average, so it's going to be y2 minus y1, which is the normal gradient that we know, divide by x2 minus x1. So this means this is going to be 10 minus 3, 5 divide by 2 minus 1. And then when you press this on your calculator, then it's going to give you 4, 5. Now 2.3. Now 2.3 says determine the equation of the tangent to h at x is equals to minus 2. Now to find the equation of a tangent, we know that the equation of a tangent is y is equals to mx plus c. And for us to find this equation, we need to know a point, right? We need to have a point and a gradient, right? So let me just call it m, right? Okay, so now the first thing that we're going to do is we already know here that we have x is equals to minus 2 as our x coordinate. So let's just substitute this and write it as minus 2. Then now the first thing that we're going to do is we're going to first find the y value and the gradient, then we're going to substitute them there. So what we're going to do is first we're going to write h of x. Now h of x, when it's updated, is going to be minus 1x cubed, right, plus 3 over 2 x squared, just double check here, plus 6x. There we go. So h of x, now we're going to substitute the value for y, for the x value here to find the y value. So now we're going to substitute the x value. So now we're going to substitute the x value to get the y value. So we're going to say y equals to minus 1 into minus 2 cubed plus 3 over 2 into minus 2 squared plus 6 into minus 2. Now when we do that, we get the value, the calculator is 3 over 2. So this means now here we have a point here. This point is minus 2 is to 3 over 2, right? Now what do we need? Second thing that we need is a gradient. So a gradient, we're going to find it using a derivative, right? So h prime of x here is going to be minus 3x squared plus 3x plus 6, right? Now remember, this derivative is at x is equal to 2. So let's go ahead and calculate h prime at minus 2. Now when we do that, this is going to be minus 3 into minus 2 squared plus 3 into minus 2 plus 6, right? Now press this on your calculator and then you should get minus 12 here. Therefore we have a gradient. We take that, we have a gradient, and we also have a point. Now let's go ahead and substitute this in the equation. Now the equation, first thing is I'm going to substitute my gradient, so it's going to be minus 12x plus c. And then now from here I'm going to substitute my point so that I can find the value for c. So I'll say 3 over 2 is equals to minus 12 into minus 2 plus c, right? So now by doing this, I get, we'll just open a small space here. So I get 3 over 2 is equals to 24 plus c. And then this means 3 over 2 minus 24 gives you c. And then press this on your calculator, you're going to get minus 45 over 2 is your value for c, right? And then therefore the equation is going to be y is equals to minus 12x minus 45 over 2. There we go. All right, so let's see if you can look over other questions. Now the next question here, it says that let's determine the x value of the point of inflection right now. So the 2.4, the point of inflection, right? It happens, that's when this was first. Now 2.4, the point of inflection, so let's call it P O I. So that's when the second derivative is 0, right? So now the first thing that we need to do is, if you remember in the previous question, we had our first derivative already. So let's take the first derivative, h of x equals to minus 3x squared plus 3x plus 6, right? Now let's work out our second derivative. So the second derivative here is going to be minus 6x plus 3. Now to find the value for x, we're going to say the second derivative, which is minus 6x plus 3 equals to 0, because that's what the condition says here. And solving for x, we're going to say minus 6x is equals to minus 3. Divide this by minus 6, divide this by minus 6. Therefore x is 1 over 2. Therefore x is 1 over 2. Let's go ahead and look into 2.5. Now 2.5 says use the graph to determine the values of p for which the equation minus x cubed plus 3 over 2x squared plus 6x plus p will have one real root. Alright, so let's explain first what is happening here. So here we want to understand which value of p, right, will make this function touch the x-axis once, right? Now here, how many times is this function touching the x-axis? 3 times. It's here and here and there, right? Right. So now, what's the first thing that we need to do here if we want to make sure that this function touches once, right? The first thing that we need to do is if we can shift this graph up here, right? So if you can shift this graph up, it means this graph is going can be it can be able to touch once in this x-axis, right? Now how can we find that? So the easy way to find this is to look at these values here, the turning points, right? Now I can see this turning point here. First thing that I need to do is I want to shift this thing up, right, to see what's going to happen. Now I can see that my turning point here is minus 3,5. So it means if I can shift this value 2 units up, this point is going to be here, right? But it's going to touch the x-axis, right? Now what about this one? This one's going to be 3 units up there, so let me just put it there, 3 units up there. And then what about this one? This one is also going to move up, but this graph will still touch here in this x-axis. So my sketch will be something like this. Let me just draw it here just to make sense of it, right? So it's going to be something of that manner, right? Let me just get a clear one. There we go, right? Now you see here, now it touches how many times now? It touches once and twice here, right? But now we want it to touch only once, right? We want this, but we want this to only touch once. So to do this, it will mean that we need to have more than just 3,5, right? More than just 3,5. So this means if p is more than 3,5, this value is going to be like sketch, or this sketch is going to be a sketch that is somewhere up there, right, but touching once on the x-axis. I hope this makes sense. So this means now the first solution for 2.5 is when if the value for p is more than 3,5. Or now let's go ahead and look for the second section. Now the second scenario, let me remove this. Now the second scenario, you can see it still touches 3 times now, which is the original one, right? Now here, the second thing that we can do, first we shift it up. So the second thing we can do is shift it down, right? Now how are you going to shift it down here? So the first thing that I can do is I can use the y coordinate of this second turning point. So which means now I can turn this thing down or shift it downwards by 10 units, right? So if I do that, this point here, this point that is here, is going to be here now, right? This one is going to be like 10 units further down, but this one will still touch the graph, right? Now, which means my graph is going to be something like this. Let me just see if I can get the clear sketch just to show you how this thing will work. All right, so you see here, the graph now no longer touches 3 times, right? But now it touches 2 times. It touches here and here, right? Now what's the one thing that I can do to make sure that it touches once? So one thing I can do is if I drop this graph further down, like if I drop it by the value that is more than 10, for example, it means now my graph, instead of touching here and here, it will only touch once. So it can only touch like this. It's gonna be something like this, but now it won't touch, remember, it won't touch the x-axis. So it's gonna be this, and then it's going to just turn there and then continue going down, right? So we can conclude that because of we shifting this down, shifting the graph down, it means now we need to have a value that is less, right? Now we shifted it down, so shifting it down means we're subtracting a number. So we're subtracting 10. So we said we need to shift it further more, right? We need to continue shifting it down more than minus 10. Hence the answer is going to be p is greater than 3.5 or p is equals to less than 10. And that's all I got for you today. Please be sure that you subscribe so that you don't miss the next video. In the next video, I'll be showing you how we can use the type tree of the cubic function to solve the questions. And I'm going to see you onto that next one. Cheers.